Mr. Madden's Math Minutes.
Sit back, relax, and get ready to learn. You give me 10 minutes or less, I'll give you a math lesson.
That's my dad.
Welcome to the video that will help you to decompose fractions as a sum of unit fractions using tape diagrams and more. First, let's discuss what we're looking at here. Here we have what is called a tape diagram, and you can see that it is divided into 1, 2, 3 sections. And those sections are divided into equally sized portions or partitions, because we are dealing with fractions where we deal with things, objects, groups divided into equal sizes. So what we're looking at here, the part up here is showing you that from here to here is equivalent to one whole. Now down below, where we have these brackets, we're looking at 3 parts that make up this whole. I'm going to zoom in on one part here, this part right here. We're going to talk about the unit fraction. A unit fraction is a fraction where the numerator is 1 and the denominator is a positive integer. So here I'm talking about one part out of 3. And likewise, the second section here, this is talking about or focusing on one part out of 3, or 1/3. And over here we have 1 out of 3. So this one whole broken up into 3 equal parts. They're showing you each part individually. A third here, a third here, and 1/3 here. Now I'm going to write what I just showed you as a number sentence. So down below I'm going to say that 1 whole is equal to 1/3 plus 1/3 plus 1/3. I could also use something called a number bond to show that over here. Here's my 1. And remember, 1 in this case is equal to 3/3. I have all 3 parts over here shaded. So I have all the thirds are shaded. So that's really equaling the whole. So my 1, let me just erase that. So my 1, I can break it into 1/3, 1/3, 1/3. So if I combine my 1/3 plus 1/3 equals 2/3, plus 1 more third equals 3/3, or the whole. Now in this example, you can see we have our one whole. Okay, from this end to this end is one whole. You can think of it as a candy bar. Okay, that's kind of the shape of what it is. And to get the unit fraction, we could look at any of these parts. I can look at this one part, or this one part, or this one part, or this one part. It doesn't matter what parts are shaded or not. I can just one part, okay, out of the whole is equal to 1/4. So that bracket showing 1/4. This bracket is showing 1/4. This bracket is showing 1/4. And notice we're only focusing on the parts that are shaded here. So, to decompose this into the shaded amounts, so looking at how many parts are shaded, I can see that I actually have 1, 2, 3 parts out of the 4 shaded. So I'm really talking about 3/4 of this bar or tape diagram are shaded. So to decompose it into a sum of unit fractions, I can say 3/4 is equal to 1/4 plus 1/4 plus 1/4. Because 1/4 plus 1/4 equals 2/4, and 2/4 plus 1 more fourth equals 3/4. And just to write that using a number bond, we're talking about 3/4, that's shaded, and I'm breaking that into 1/4, 1/4, and 1/4. In this example, okay, again, from this end to this end is one hole. So imagine this is one whole candy bar or tape diagram. However, this time look at the brackets. The bracket is focusing on more than one part at a time. So if I just asked you what the unit fraction was, you would count up how many parts there are, 1, 2, 3, 4, 5, 6, and you would say that the unit fraction is 1/6. However, here the brackets are focusing on more than one part at a time. So I'm going to label that this bracket here is focusing on 3/6, right? Talking about 3 parts, 1, 2, 3, out of the 6. And this bracket over here, guess what it's showing you? 2/6. So the combination of those, if you look at the entire thing, is 1, 2, 3, 4, 5 out of 6, or 5/6. So my number sentence would be 5/6 is equal to 3/6 plus 2/6. Because we're talking about 6, so we're not combining the denominators, but we do combine the numerator. 3 parts here and 2 parts here. To make it as a number bond, over here I would write 5/6, and then I break it into 3/6 and 2/6. Now in this diagram, take a look. We have one hole which actually starts here and ends here. So the question is, what is this? Well, that is more than one hole. That's the next part of a next hole. It looks kind of strange because they are all connected. So if we just focused on the hole and think about what's the unit fraction of this hole, it's divided into 1, 2, 3, 4 parts. So the unit fraction here is 1/4. So I could draw the one hole. I'm going to separate it from this fourth that's added on after the hole. So just down here I'm going to create another tape diagram. My hole is made up of 4 parts, and then there's another hole that started. I'm going to divide that into 4 parts. Now I'm going to shade. So there's my one hole that's shaded. Now on the next hole, which we see all of it down here, how many parts am I going to shade? Just 1. So that's what it looks like if I draw 2 holes. If I combine them and cut off these parts I'm not talking about, I'm really focusing on this. So what do I have here? Here I have one hole, and here I have 1/4 of the next hole, for a total of 1 and 1/4. I could write that also if I say I have 4/4 shaded here and 1/4 shaded here, and I combine those two, like I combined the numbers down here, I would get, add my numerators, okay, both pieces are divided into fourths, so they stay fourths, so I have 5/4, which is equivalent to 1 and 1/4. So up here I have the whole thing shaded, 1, 2, 3, 4, 5, so I'm dealing with 5/4, and that is equal to, and I'm going to look at my brackets here, and my first bracket I have 3/4 shaded. This bracket here is only 1/4 shaded, and this last bracket also has 1/4 shaded. So down in my number sentence I can say that 5/4 is equal to 3/4 plus 1/4 plus 1/4. Okay, just thinking that adding my numerators, 3 plus 1 plus 1 gives me 5, or the 5 shaded parts. Now what we're going to do in this slide is I'm going to draw and label tape diagrams to model each decomposition. So here is my first decomposition. 1 equals 1/3 plus 1/3 plus 1/3. So I know that 1 is my numerator. That means 1/3 is my unit fraction. So I'm going to create a tape diagram. I'm going to divide it into thirds. Okay, I could always label this as my 1/2. And down here is 1/3. Here's another bracket showing 1/3. Here's a third bracket showing 1/3. And of course I would shade in all of the thirds, because we're saying 1/2 is equal to 1/3 plus 1/3 plus 1/3. In this next problem we have 6/7 is we're saying is equal to 1/7 plus 3/7 plus 2/7. So I'm going to draw a tape diagram, and dividing into sevenths can be tricky. 1, 2, 3, 4, 5, 6, 7. And I'm going to label my whole, which would be 7/7. And then I'm going to go down and break it up, decompose it based on the 3 addends I have above. So the first one is 1/7. Then I have 3/7. And then 2/7. Notice I'm not bracketing off the whole bottom here, because based on my total here, we're not talking about the whole, we're talking about 6/7 of the whole. So then I'm going to just shade in the 1/7, 2/7, 3/7, 4/7, 5/7, 6/7. And there is my tape diagram with my labeling. Now this problem looks a little odd maybe, because we have 8/5. Since our numerator is larger than our denominator, we know we're talking about more than 1/2. So what may help me is to come over here and make a number bond, right? 8/5. And I'm going to divide it first into how many wholes can I get? How many fifths make up a whole? 5/5. And then what is left to get to 8? 3/5, because 5/5 plus 3/5 will equal my 8/5. So I know I'm going to have 1 whole and 3/5 shaded. So that can help me make my, or draw my tape diagram. I know that my whole is going to be fifths. So this is 1 whole, or 5/5. And then I know I'm going to need 3/5 more. Took care of my whole. Now I'm going to add on my 3/5 right there. So now I'm going to label the bottom. So my addends here are 1 plus 1/5 plus 2/5. So first I'm going to mark off 5/5, my whole, then plus 1/5, and then 2/5. And then I will shade in my 1 whole, plus 1/5 more, plus 2/5 more. And now if I count up all of my unit fractions here, 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5. And that is my total with my tape diagram and my labeling. Thanks for watching this video on decomposing fractions as a sum of unit fractions, and sometimes not, using tape diagrams with some number bonds thrown in as well. Have a good day. This is Mr. Madden saying thanks for watching. I hope it helped, and whatever you are, be a good one.